Hello and welcome to my second part of this series. In this video we will cover the basics about global coordinates. Let's begin with this map of Stanton I grabbed from the ArcStar map. In this video you might notice that this version is still different from the ArcStar map because it does not represent the actual in-game state. Just to name a few examples, the y-axis is swapped, the star is located above the planets, and the locations of the planets do not represent the actual in-game positions. Therefore, I had to modify this for my needs so we can see the actual in-game situation. To understand this coordinate system, we first need the axes that are used by CIG and Star Citizen. If you have followed my previous video, you already know there exist 3 of them. The X and Y axis on a horizontal plane and the Z axis for the vertical axis. Some might recognize this from a real-world system called Cartesian coordinate system, which is pretty much the same. With it, we can identify any spot in the 3D space. At the current state of the game and game logics, we expect that the coordinates follow the same principle in each system. After new systems got introduced, we have to liver the system together with these coordinates to fully identify a spot in the verse. Let's get over to the next part and enable the planets. And label them, of course. Each planet, Lagrange point, star or jump hole has a fixed position in the Stanton system that can be located by its global coordinates. We call these coordinates global because they apply to the whole 3D space within a system. As soon as you enter an object container that is moving or rotating, these coordinates are not applicable anymore. So keep this important fact in mind. If you don't know what an object container is, it's everything that has its own set of, we call it local coordinates, like planets, Lagrange points, just to name a few. Ships, for example, are an own object container within another, and so it's a nested system. But where do we get these coordinates from, you might ask? At the moment, there exist multiple ways we can grab these from. One common known is data mining, but this applies to only a few people. The most important utility for navigation is a debug command CIG introduced for quite some time in Star Citizen. It's the show location command. It's used like an emote in the in-game chat. You can choose any channel for that. So, at the top of the screen you can now see it. After the command was sent, it does copy your current coordinates into the clipboard. This is pretty useful because now we can directly tell the player's location in the system. These values are very precise while maintaining a greater range at the same time. Let me explain this to you. Now you can see what the command creates in the clipboard. The numbers you see here are my coordinates I grabbed from Wolf Point 8 shelter, an outpost located on Daymar of Crusader. Thanks to CIG's conversion of the engine to 64-bit floating precision, we have achieved the ability to create a whole system while placing tiny objects reliable at any spot. If we break down these numbers, we see that we have distances in the range of gigameters as well as micrometers. In a later video, I will return to these numbers and talk about the scale of Star Citizen and the verse. Now I will enable the coordinates of each planet in Stanton for some showcases. If you compare all the 3 values from the clipboard content with, for example, Planet Crusader, you see that the leading numbers are almost equal. So from this standpoint, we can surely tell that I was located near Crusader while I created these coordinates. Short note, the values you can see here might change in the future, because CIG might move the planets in future patches. As you can see, each planet has its own position and all are placed on a flat plane sitting directly on z equals 0. This is correct for most objects in Stanton, except a specific one, the Stanton star. It was raised way above to simulate a tilted day and night cycle on planets like we experience it here on Earth. So this is already pretty useful for us in 3D space. But what about moving or rotating objects, you might ask? We will cover this topic in the next video, where I will show you what local coordinates are and why we use these to feed our nav tools for planetary navigation. So, see you in the next video.